back to It's a Science Thing. Thanks for joining me. Today we're going to use balloons again, but we're going to use balloons in a different way. Last time we used balloons, and I did some experiments to demonstrate different ways to inflate the balloon besides just using my breath. Today we're going to use balloons as a means of moving other objects. And as we do this, we're going to go over a famous mathematician and physicist named Isaac Newton. Oh, I have a picture of him. Right here. We're going to go over his theories of motion. He's got 3 of them. Motion is movement. He was around in the 17th century, and he is the person who was largely responsible for the theory of gravity. He also is responsible for coming up with a form of very complicated math called calculus. And he also is famous for coming up with these 3 laws of motion or movement. So we're going to use balloons to demonstrate those today. The first thing that I'm going to do is make this move with a balloon. Everything that we're going to make that moves today is going to be powered by the balloon. So the balloon is going to be sort of the engine. This is a very thick straw. It's the kind of straw, you get thin straws when you go out to eat. Usually they're just bendy, thin straws. This is a little bit thicker. It's the kind of straw you might get if you want to drink a milkshake or something like that. It's a little bigger, a little round, a little fatter. On it, I have these 2 orange pieces of reflective tape so you can see it as it moves. It is on this stuff that's fishing line. It's very smooth, and it's kind of invisible, so you may not be able to see it. So I also wanted you to see that it's on. That this is here. It's not just floating in the air, and so it moves pretty smoothly. I'm going to take a balloon and tape it on here. If you want to do this at home, because it's fun to try to make rockets and things, taping it when it's inflated is a lot easier. I tried it the other way and tore the balloon. So, when you do this, one of the things you want to think about, I'm using electrical tape here so you can see it better because it has a color. You're going to make it so that the nozzle, or the place that you blew the balloon up, is straight, facing straight. I had it one time like this, and it does not help to make this move because it's shooting out that way. And we'll discuss how it needs to be exactly opposite in order to make it shoot. So, right now, this is going to demonstrate Newton's first law. So he's got three laws of motion. The first one is saying that an object at rest will stay at rest, and an object in motion will stay in motion until an outside force acts upon it. So, if I didn't have a balloon attached to this, and I wasn't touching it, and I put this on here, and then I went and disappeared for 100 years, and nobody else ever came into this room, this would probably sit here until something comes in and moves it, or something happens on the outside. Maybe a breeze would come in and make this wiggle, or maybe this would, somehow rot and fall apart, and the string would fall, then this would move. Maybe there's an earthquake, and then this might move. Some outside force has to act upon this to move this straw, and if not, it will just sit here forever. It's inertia, basically, is what that's called. It's a theory of inertia. At the same time, also, if something is moving, it will keep on moving until something slows it down and eventually stops it. And we'll talk about that after I let this go. So I'm going to let this go, and we will just observe before we do anything else. So here we go. Ready? Oh, slow start. So this moved, and it stopped because it bumped into here, into the sign. It also stopped because it ran out of string. It stopped because it ran out of the pressure. It ran out of its motor. There's no more air. When the air runs out, this thing stops moving. So there are different reasons why this stopped. If those things weren't the case, and the string went on forever and ever, there was no building or anything to get in its way, it would just keep going and going and going and going until something slowed it down. When I originally put this together, I did not use fishing line, which is very, very smooth. I used yarn, and yarn kind of has little threads that stick up, and that slowed it down, so it was not that smooth. I also used a smaller straw, a thinner straw, and that was really, the threads really got in its way. So it slowed it down, it added friction and slowed it down. It did not move very well at all. An outside force was acting on it. So, this also helps to demonstrate Newton's third law. We're going to go to the second one afterwards. The third law is that every action has an equal and opposite reaction. So, when I blow up this balloon, let me blow it up and I blew up the balloon, that was an action. It blew up, right? It expanded. Now, what's going to happen here is, I'm going to let this go, and the air is going to get released, and that is the action. The air is leaving the balloon, but there will also be an equal and opposite reaction. So the air is leaving the balloon this way. So which way do you think, if it's the opposite, will the balloon go? Guesses? I will let you guess and let it go, and you can see. Well, you know because I did it before, but this kind of explains it a little bit, right? When I open this up, the balloon goes this way because it's the opposite direction of the action, which is the air coming out here. Now, if I flipped it around, which is too hard to do because it would require, I wonder if I could do this without, no, the balloon will break. If I switched the balloon around and the air was coming out this side, the balloon would go that way because it's opposite. And the balloon is moving as fast as the air is moving because it's equal and opposite. That is Newton's third law. Now, Newton's second law is that the acceleration of an object is produced when a force acts on the mass of an object. Acceleration is how fast it's going. So with this, I already did discuss that it was slowed down by a couple of factors, having to do with the string, the size of the straw. But also, initially when I made this, I wanted to make it look like a cool rocket. So I made a sort of rocket out of a toilet paper tube. I added all these streamers so it looked like flames coming out. This ended up being too heavy. And it did not go very well at all. Even though the balloon was the same size, this was heavier and required more to make it move. So that is sort of what the third law is, having to do with the size of an object and the amount of force needed to move it. Sort of, if you think of it this way, if you had, let me think, you had a car that was a large car, and one person tries to move the car, it broke down, and they're trying to move it off the road. And one person tries to push that car. The person struggling, maybe gets to move a little bit, and it's very hard, and it's going very slow, and it does not go very far. But if you had two men or women pushing the car will go twice as far and twice as fast. It'll go because there's two people working on that same size car. If you have three people, it would go even faster. But also, if you think about it, if the car was a smaller car with one person working on it, the car would move faster and a little further as well because the one person could move the smaller mass further. So it's all a ratio between the size, the mass of an object, the weight of an object, and the force being pushed against it. So this was too heavy. Even though the balloon was the same size, it was not enough to move this as fast as this is moving. And so one of the things that you can do that's kind of fun is if you had a way to set up two strings next to each other and come up with rocket ideas with a friend or another person and have races That can be kind of fun, and you might try to adapt this to try to figure out what would make mine a little faster than the next person, than that person's. So having balloon races would be fun, and you can do that at home. So now we're going to use balloons to move other things as well. Okay, so another vehicle that I made that would be, it's going to be powered by the air that comes out of the balloon, so the balloon is sort of its motor, is a boat. And this boat is the very bottom of a, I think it was rice milk or almond milk container that I cut and made a hole through the bottom and put a straw in. I will actually later close up show you how some of these things can be made. But I just want to demonstrate this outside in this pool. So the balloon is our motor. The air is going to come out the exhaust here that way. So let's see. I don't even know how this is going to go. We'll just see what happens. Oh, it moves a little bit. Let's try again. The reason I did it in the almond milk containers because it can hold, obviously it's holding milk, so it's water, it can hold water, and it can sit in water without disintegrating. If you make a boat out of paper, it's just going to get soggy, right? Or a box, it's going to get soggy. And we also covered it with duct tape to keep it waterproof. Ready? Let's do it in the middle and see what happens. It's moving, and it's moving the opposite direction than the exhaust pipe. I mean, this is sort of like a little exhaust pipe here. So you can make boats too. And that could be kind of fun to do. See what happens if you make the boat out of something lighter, or if you make the boat smaller, or if you make this taller. Will it move any faster or slower or any differently? Also, I mean, say I used a balloon that was bigger. These are just standard size balloons, but if I used a really big balloon, what would happen? Would it go faster or just longer? Right? Different things influence the movement of something, right? There are all kinds of factors that can cause something to go slower or faster or stop it moving. Obviously, this is going to stop moving because the balloon's going to run out of air, which is true for all the vehicles. Once the air is gone out of the balloon, the force is done and there's nothing acting on it to keep it moving. So it's going to stop moving. Let's see. Go, 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 go. So you could have races with boats too. So that is another vehicle powered by a balloon. Okay, so I have to get down low because you need to see some things that are going to be moving on the floor. We're going to use balloons to power some other things. We used the balloon to power the rocket before. This time we're going to use the balloon to power some cars that I made. The cars are made out of things that I found around that you might be able to find in your house. The first one is a car that I made out of a staple box from Staples, but it is a staple box that held staples. It's empty now, and I put tires that were bottle caps, and I used tacks to keep them on as a sort of axle, just little individual tacks. Then I taped a straw to the top with a balloon, and we'll see how this one moves. I'm going to blow it up, and hopefully you'll be able to see it through the camera there. Ready? Okay, so I'm going to put it down. The balloon is here, so the air is going to come out here and it's going to move in the opposite direction, so it's going to move that way. And let's see how it does. Ready? Go. Not so great. Not very impressive. Let me try that one more time. There seems to be some issues. Let's try this again. This time it should go that way. Go, 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 go. Okay. It did not move very well, but there are reasons why. It was being stopped. There was a force acting against it. And there's several things going on here, I think. One being that the hole for each tap to go through, I don't think is completely centered in the middle of each cap. So they are not moving in a perfect circle when they're going around and around. The caps also have, I had to break the seal when you get new water, and that left a little sort of ragged edge that I think is catching on the carpet here. The fact that it's a carpet might make a difference. It also might be that this is pretty low to the ground and the blown up balloon might have been causing drag. It might have been dragging and slowing it down. There's a lot of resistance happening that's slowing this vehicle down. And these also aren't completely tight this way. So they're kind of going like this and maybe even bumping into the box. So this is not the most successful design, but we can think about it and explain why and maybe make some changes. I made another one. I decided, okay, that one didn't work so well. Let's try something different. So I made one out of a Scotch tape box, which is a different shape. It's a square. It is also low. I made the wheels different. The wheels for this vehicle are, this is a dowel, which is just like a wooden rod that I cut short, and I hot glue gunned some bottle caps there. These bottle caps don't have that break area, the safety catch that I had to break through so it's smooth. There are no little pieces like those wheels. This is going to spin within this, which is a receipt roller, so it spins a lot smoother than those separate wheels. 2 spin together at a time for this. I made 2 of these axles, and then I glued them to the bottom of the box. Now you can see they move. So that could cause an issue. I'm going to try and see, let's see how this one goes. If you go like this, it does seem to go better than the other one, doesn't it? Just with my own hand. This one really does not go very far even when I'm using my hand. So let's experiment and see what happens. Another difference is that this car, I used a skinny straw like you would get at a fast food restaurant. You know, the bendy kind. I used a skinny straw. This is a big straw. Don't know if that'll make a difference. Ready? So I have the balloon here. The air is going to shoot out here, so I better move it back. Who knows how fast it's going to go. Ready? I have high hopes for this one. Ready? Go! Okay. Not a little less impressive than I thought it would be, but hold on. One more time. Maybe I have to center it. I think one of the issues is that this is moving, and that is not helpful. Maybe it's not making it a smooth ride. Here we go. Ready? Go. I kind of caught on the end. So this one I think does have a smoother ride, but it still has issues. I think the axles are too big. It also could be that, yes, the straw is bigger and maybe lets the air out faster, but that also makes it heavier. This one is actually heavier than this one. You can probably hear it. Right? So 2 different designs. You know, you could think about what you might do differently to make this work better, or go further or faster. And this is my last design. This design, these are not wheels that I made. You might recognize them. They are Lego wheels. I glued Lego wheels to the bottom of this box. I can take them off though, so we can use the Lego wheels again. This box is a lemon extract box. from the kitchen, and I covered it with tape, duct tape, glued the Lego wheels, and this is a fat straw, and the balloon is on the top of this box. It's a different shaped box. It is a tall, skinny box. The other ones were sort of flat and wide. This is tall and skinny. Maybe it'll make a difference. Maybe it'll make a difference because the balloon won't be low and rubbing. I'm not sure. Let's give it a try. Let's have this one move this way. Air's going to come shooting out here, so it's going to go in the opposite direction. Ooh, that was better. That was better, a lot smoother, right? It does better on the carpet than the other ones, and that might have to do with the fact that this actually has like a wheel, which you probably know. It's like a rubber wheel. So that works better on the carpet. I don't know, maybe being taller makes a difference. Maybe being thinner makes a difference. I don't know. It's all kind of trial and error. I'm gonna let it go again. Ready? 1, 2, 3. So there we go. I think this also stops because the balloon gets in its way, kind of. It gets under the wheels a little bit. This could go further, actually. Also the size of the balloon. If this was a big, big balloon like that one I used over there, I wondered how far it would go. Imagine if I filled up that balloon and it didn't pop, and it was huge, and I let it go, maybe this would go all the way across the room. I don't know. Does a bigger balloon make it go faster or further or both? So that is experimenting with vehicles that have wheels and using a balloon as its motor or its engine. You could also do a three-wheeled thing if you wanted to. That could make a difference, right? So maybe find some things around the house and ask an adult what you are allowed to use and not allowed to use. I'm going to show you a little bit later how to make some of these things because it will require adult supervision as you make some of these.